Okay guys, a few questions were asked about the 10.3 worksheet, so I thought we'd go through a few of those, starting with number 11 here. Directions here tell us to find the area of each regular polygon, and those directions are important. The fact that the polygon is regular is why this problem belongs in section 10.3, and there's nothing in the diagram to indicate this. We wouldn't want you to assume, but the fact that they told us that it's a regular polygon means that all three of those sides are all going to be congruent, which means they're all going to have a length of 20 centimeters in this problem. That also tells us that because it's a regular polygon, the formula we're going to use here is the one we've been talking about in 10.3. That area of a regular polygon is going to be 1/2 times the perimeter of that polygon multiplied by the length of its apothem. Okay, so let's go to step 2 and fill in what we know. So area then is going to be 1/2 multiplied by our perimeter. Well, the fact that it's a regular polygon, all three sides are 20 centimeters, means that our perimeter is going to be 20 times 3, which is going to be 60 centimeters. The hard part of this problem is trying to come up with the length of the apothem, which wasn't drawn for us. And the apothem, if you go back and watch those notes again, is a line segment that always connects the center of a regular polygon to the midpoint of one of the sides here. And it's perpendicular to it as well. So that little piece right there in blue is the apothem. And then right next to that, we always like to go to one of the vertices of the polygon, and that's going to be our radius. Now, this is something that would benefit you guys if we just had this memorized here. But if we don't, let's talk about the proper way to do this right here. In any regular polygon, I'm going to switch to a green pen here. In any regular polygon, if you were going to draw two radii, so this one and then the one that I just drew right over there, you form what's called a central angle right here, and we normally call that theta. And the way to find the measure of theta is always going to be 360 degrees divided by n, which is your number of sides. Well, in this case, n is 3 because we're just dealing with a triangle here. So it's 360 divided by 3. Theta then is 120 degrees. That's the measure of this central angle right in here. This angle right next to it is always going to be half of theta. So I'm running out of room right here. Let me redraw this little triangle right here down on the bottom. It kind of looks something like this, where this was our apothem, here was the right angle, and this was the radius. And if we're talking about this angle right over here, that angle is always going to be half of the 120 degree central angle that we came up with. So that's going to be a 60 degree angle every time we're dealing with a triangle. Well, we now know that we have a 90 degree angle and a 60 degree angle, which means this one right here has to be 30, and now we can see that we're dealing with a 30, 60, 90 right triangle, where if we know one of the side lengths, we can find the other two pretty quickly. The key to that is that one full side of this triangle is 20 centimeters. So this little piece down here, which I very often call x, is going to be half of that 20, which means we're dealing with a 10 centimeter side right down there for the long leg of that 30, 60, 90 right triangle. Now the key here, what we're still missing is to try to find the apothem. That's what we're looking for right here, and that number is going to go right here. So to figure out the value of A, we got to go back and review what we know about 30, 60, 90 triangles. We know that the long leg down here is 10. We want to come up with the length of the short leg. To go from short leg to long leg, we multiply by the square root of 3. So to go backwards from long leg to short leg, we're going to take 10 and divide it by the square root of 3. Now this one doesn't work out nicely, but if you go to your calculator, it's going to rationalize it for you and tell you that it's 10 root 3 over 3. And guys, that's ugly, but that is the best that this thing is going to get. So let me get rid of that red line there because that's going to confuse us. And the length of our apothem is 10 root 3 divided by 3. Okay, so that was step 2. That was really the hard part. And now step 3 is to just put all of this together. And again, you can just go to your calculator if you want to do it this way, but this one isn't that bad to do by hand. Half of 60 is going to get us 30. The 30 divides by this 3 here. So 30 divided by 3 gets us a 10, and the 10 times the 10 root 3 is going to give us 100 times the square root of 3. Both the perimeter and the apothem were measured in centimeters, so that's going to be 100 root 3, nope, not cubic centimeters, sorry, 100 root 3 square centimeters. And that's the exact value of the answer right here, which is how I would actually prefer it. But the directions did ask for us right here, guys, to give it to them to the nearest tenth. So when I type that into my calculator, I would write that my area is approximately equal to 173.2 square centimeters. So that second answer is actually what they wanted right there, but I actually like that first one a little bit better. Okay, that's a wrap on number 11. Hopefully 10 and 12 went okay then for you too.